Uh, Thank you, Chair. Yes, I am available.
Okay, please, you can start your presentation, and remember the time of presentation also. Thank you.
Is my presentation visible?
Yes, it's visible.
Thank you. I'm Dr. Ghulam Murtaza. I'm representing Department of Pharmacy, COMSATS University, Lahore campus. My presentation focus is on antibacterial nanocomposite films that we prepared for the treatment of infected burn wounds. In my lab, we are mainly focused on topical drug delivery systems, including ocular formulations as well as transdermal drug delivery systems, especially for skin wound healing. You know, skin is the largest body organ. Healthy skin has three layers that could be named as epidermis, dermis, and hypodermis, which are further subdivided into several layers. Its main functions include protection, regulation, sensation, and which are dependent on the structure's integrity of skin. Skin functioning is adversely affected when there is some injury. Skin injury could be due to some cut or burn. Burn is mainly induced by chemicals or fire. Skin burn could be of first degree, in which epidermis is affected. It could be second degree, in which epidermis and to some extent dermal layer is affected. And third degree, in which damage approaches the fat tissues. Burn wounds, especially deep tissue burns, are very prone to bacterial infections, which could be due to certain bacteria, such as Pseudomonas aeruginosa, E. coli, Staphylococcus aureus, and Streptococcus pyogenes, which are closely related to chronic wounds, and Staphylococcus epidermidis, which is linked with acute wound. Traditionally, treatments such as ointments and creams are widely used to assist the treatment of the wounds. However, their frequent application, inability to absorb exudates, and need for repeated washing of wound bed and poor drug penetration results in poor healing, which may lead to chronic wounds. Particular safety protocols are needed for wound decontamination and therapeutic purpose that can be achieved by using wound dressing, which controls the biochemical conditions of the wound to aid the healing process. No wound dressing is ideal, but a dressing must meet the minimum requirements. What are the minimum requirements that a dressing must have? It must be mechanically stable for convenient application. It must have porous structure for exudate absorption and maintenance of adequate moisture. It must protect the wound from bacteria and dust. It must allow air permeation and oxygenation. And finally, it must control the release of drug for prolonged drug effect. Various wound dressings available today could be categorized into conventional dressings, which are not loaded with any drug, such as gauzes, biological dressings such as skin transplantation, including allografts and xenografts, and polymer dressings such as polymeric nanocomposite films, which are occlusive in nature and may contain antimicrobial agents. This is the area of research which we have adopted in our lab. In this study, we prepared silver-polymer nanoclay nanocomposites. You know, nanocomposites are available in variety, including polymer matrix nanocomposites, ceramic matrix nanocomposites, and metal matrix nanocomposites, in which different metals could be used, including gold, cobalt, silver, etc. A variety of natural polymers as well as synthetic polymers has already been used and continuously has been used in the development of drug delivery systems, including nanocomposites. In this study, we used chitosan, pullulone, and sericin. It was a big project. Additionally, we used nanoclay that is well known for its improved mechanical properties and for sustaining effect on drug release. And finally, for the management of infection and control of bacteria, we added moxifloxacin in the preparation of these nanocomposites. This is a brief summary that we followed for the preparation of nanocomposites. You can see that we prepared silver nitrate chitosan mixture. Afterwards, we added sodium borohydride for the reduction and preparation of nanoparticles, and different steps were adopted, which are visible in this figure. And finally, we acquired the composite film. In second scheme, we added sericin solution in different ratios, as evident here, 1, 2, and 3%. And the same procedure was used for the preparation of nanocomposites. And the third polymer that we used for the preparation of matrix, that is the pullulane, and the rest of the procedure was same as I shared in the first one. Afterwards, we characterized these nanocomposites through various techniques, including in vitro chemical evaluation. And these were the different evaluation studies we conducted. And then in vitro antibacterial activity using agar disc diffused method was conducted. Gram-positive and gram-negative and clinically isolated bacteria were used, and marketed controls were also used. In vivo evaluation was also conducted for the assessment of burn wound healing. These different studies were conducted for this assessment. These are the brief presentations which are representing the important findings. To be very much precise and to manage my times, I'm not going to individual findings. All the formulations that depicted particle size less than 165 nanometer, following the definition of nanoparticles, and an acceptable polydispersibility index was observed in all the formulations, and negative zeta potential was there. Drug content uniformity was seen. You can see that I have labeled the diagram in the right upper corner, center and periphery. Drug contents was equally distributed in the center of film and its periphery. And all the formulations showed an excellent loading efficiency that was more than 97% in all the formulations. Why I used sericin and pullulane, and why I incorporated it into chitosan as compared with pure chitosan films. nanocomposite films showed comparable properties such as mechanical properties, swelling ratio, and film solubility, except antibacterial activity that was higher of nanocomposite films. After the incorporation of sericin, I observed that there was improved mechanical properties, swelling ratio, film solubility, and antibacterial activity of sericin, chitosan, nanocomposite films, while pullulan reduced these features except antibacterial activity. Both sericin and pullulan induced a slow release of silver ions as well as moxifloxacin. Sericin and pullulan-based nanocomposite films fitted well to zero-order equation, which represented that the drug release was very much slow as we need for prolonged drug release. We also determined the quantity of silver ions in the blood, and the nanocomposite films indicated no silver species release in the diluted blood samples, except one formulation in which drug concentration was, silver nanoparticle concentration was 0.119 ppm, and that was in the allowed limits. Percentage wound healing is evident from this table. At day 7, you can see that the untreated groups, group 1, 2, 3, and 4, you can say that there was swelling, redness, bleeding, and infection. However, moxifloxacin solution labeled as G5, chitosan film, sericin film, and marketed control bactigras indicated that there is a significantly improvement in wound, and there was no swelling, no redness, no blistering, no bleeding, and no infection. This is the pathological and photographic view. It's evident from this photographic view that there was a drastic improvement in skin wound as compared from the day 0 and day 7. So, according to conclusion, successful development of topical moxifloxacin-loaded polymer nanocomposite film that promisingly facilitated the healing of infected wounds, showing prolonged release of antibacterial agents, and chitosan nanocomposite films as well as chitosan sericin blends exhibited the most promising findings in this context. This project was belonged to my PhD student, and we published this data to these journals: International Journal of Biological Macromolecules, International Journal of Pharmaceutics, International Journal of Pharmaceutics, and Journal of Drug Delivery Science and Technology. Thank you very much for giving me opportunity to present my work over here. Thank you.